we are going to discuss about two important features as part of this asynchronous programming. First one, future methods. Second one, queuable interface. This is also called as queuable apex. Then first of all, we have to understand what exactly the future methods, what it indicates. Now, let's see. So now in this case, let's see the functionality here. Let's observe this word clearly so that we can understand what exactly the functionality of future methods. You know this word method. We know this word method. That means it's like as a procedure which contains some business logics to be used to perform certain operation. So method means it's a subprogram. It may be a procedure. It may be a function which contains some business logic inside that. Now, which contains some business logic inside this. So now tell me generally, once a procedure has been getting prepared, how can we invoke the procedure? We are invoking the procedure by using execute anonymous window. We'll go to that execute anonymous window. We can call the procedure here by using object name dot procedure name, or if it is a static procedure, then we are calling them by using class name dot procedure name. So, whatever the methods or whatever the procedures we have prepared as part of our application development, so which contains some business logic to perform the operations, those procedures we can execute from execute anonymous window. Okay? Now, so now here in this case here, whenever we are invoking the procedure, let's see, for example, I'm preparing a procedure. Public static void get all accounts. Here we are writing some business logic. Whatever the business logic that you want, we can able to write it. Now, so once a procedure is ready, that means once a method is ready with the required business logic, we can execute them by using execute anonymous window. We can call them by using class name dot method name. Method name is what? Get all accounts. Because it's a static method here, static method can be accessible by using class name dot method name. So now whenever we are going to be calling this a method, the method will be executing within my organization. Within my organization, the method will be getting executed. Now, so now as soon as once you call this a method, immediately the request will be sending to the Salesforce server. Now the server will be considering my request. It will accept the request. It will execute the method. It will be sending the response back to me immediately. Now, so now in this case, for example, sometimes in this method, I'm writing some business logic which is used to perform the operations on some crores of records. That means millions of records, which is a long running operation, which will take some more time to process, which includes some millions of records processing inside that, which may be used to interact with some third party systems also through integration. In the case here, whenever I'm executing this method, if it is taking more time by the Salesforce server, then within the organization, I can't do any other operations here. For that reason, what I want to do is, whatever the method that I have prepared, this method is including some millions of records processing. It's a long running operation. So I don't want to execute this method within my organization. I want to execute outside of the organization. Outside of the organization means by placing inside Salesforce queue. So in this case, whenever if you want to execute a method by placing inside the Salesforce queue, then we can able to use a method of type future. Okay, future method. Now, so now here in this case, future methods are not executing immediately. Future methods may be executing in future. In future means what? Maybe immediately also, maybe after a few minutes, after a few seconds, after a few hours, after a few days. Then when based on the availability of Salesforce resources, based on the availability of the server, based on the availability of the resources, it will execute the method by placing inside the Apex queue. So now here in this case, whenever if you want to execute a method, okay, by placing inside the Apex queue, then we can define the method as future. Then how can we make this method as future? Just before starting this method, we can able to use the annotation the rate future. That's it. Okay. If I'm not adding this particular at the rate future annotation, it is a synchronous method which will execute within your organization immediately. Now, if you're adding this annotation at the rate future, then it will be a asynchronous operation which will execute by placing inside the topics queue whenever the resources becomes available. Whenever the Salesforce resources becomes available, then it will execute the method, maybe immediately also. Suppose if the server is available right now, if the server is free or idle right now, it will take up this request, it will execute immediately, or else it will take some time. It may be after few minutes also it will execute, few seconds also, after few hours also, after few days also. Depends upon the availability of the Salesforce resources, it will execute this method. So in this case, if you want to execute the method by placing inside the Apex queue, we are going to be defining the method as in the rate future. Okay. Then, why we are using these future methods? Future methods are used to implement long running operations. Long running operations means what? Which will take more time to process. When it will take more time to process, if it is having some complex operation, if it is having some more number of records to be get processed, if it is having some integration mechanism to connect with our third party system, it may be having some features to synchronize the data to the third party systems also. In this kind of scenarios, it will take more time, so that here these kind of long running operations don't execute within the organization, execute them from outside of the organization by placing inside the topics queue, so that I'm defining this method as at the rate future. Okay, understand the concept here? So future methods are always executing in future. That means based on the availability of Salesforce resources. Till that time, these methods will be placing inside Apex queue. Understood the concept here? Now, so now this is one way here in order to prepare this future method. Now, so by using these future methods, we can able to avoid a problem that is called as mixed DML operation exception. By using this future method, we can able to avoid mixed DML operation exception. Then what do you mean by this mixed DML operation exception? Okay, now let me explain. Now, as part of my Salesforce arc, okay, as part of my Salesforce arc, we are having, okay, so many objects are available. Inside my Salesforce arc, we are having so many objects. In my Salesforce arc, we are having so many objects are available, including standard and including custom. We have so many objects are available. We have standard objects and we have custom objects. So whatever the standard objects and custom objects that we have, these will be called as what? Yes objects. So the combination of both the standard and custom objects will be called as yes objects. Okay. Now, so now in this case, in Salesforce, whatever the Salesforce objects that we have, these Salesforce objects has been divided into two categories. Okay. Whatever the Salesforce objects that we have, these Salesforce objects has been divided into two categories. First one, setup objects. Second one, non-setup objects. First one, setup. Second one, non-setup objects. So, whatever the Salesforce objects that we have, these objects has been divided into two categories like setup objects and the non-setup objects. Then what do you mean by setup object? What objects are comes under setup objects? And what do you mean by non-setup objects? And what objects are comes under non-setup objects? Then what is the problem upon using these objects to perform the DML operation? And why this mixed DML operation exception will get arise? How to solve this problem by using these future methods? Now let's see. Now, so basically, setup objects are used to interact with the metadata through declarative development. Setup objects are used to interact with the metadata through declarative development. Metadata means what? Feature. Okay, metadata means it's a feature available inside my R. Through declarative development here, declarative means what? Without writing any code, without using any programming languages, just by using some mouse clicks. So there are some features are available in Salesforce which we can interact with these features through programming, through by using mouse clicks over there. Now, so now here those are available in the form of tables. Now, so in this case, setup objects are used to interact with the metadata through declarative development. Now, in this case, setup objects can be operatable or manageable by using setup area or builder area of Salesforce. Setup objects can be manageable by using setup area or builder area of Salesforce. Now, so that means simple concept here. So now, whatever the features that we have inside our Salesforce, some features are available in the form of objects. Those objects were interacting through mouse clicks over here. Like for example, let me explain. For example, here, assume that we have user. User is what? A feature. But that feature is available in the form of an object. What is that user feature available? User object. Okay, user object. Next, we have profile. Profile is what? It's a feature which is used to grant the permissions inside that. But this is available in the form of object. And then we have validation rule. It's a feature to validate the data, but we can able to interact through mouse clicks. And then we have page layout. It's a feature which is used to represent the fields that we have created inside your object. But this will be available in the form of an object. We have lookup filter. Lookup filter is a feature which is used to make sure upon click on the lookup icon, instead of displaying all the parent records, we can restrict some records to be get visible. For that one, we are configuring lookup filter. It's a feature, but this is available in the form of object. And then we have business process. This is also available in the form of object. We have email template. This is also a feature which is available in the form of an object here. And then we are having group, public group. So not to store a group of users, but this is available in the form of an object here, group object. And then we have workflow rule that is also available in the form of object. We have workflow email alert. This is also available in the form of object. Workflow field update. This is also available in the form of object. These are all are the features of Salesforce, but these features are available in the form of objects. So setup objects are used to interact with the metadata through declarative development. These are all are the features of Salesforce. These are all are features of Salesforce, but these features are available in the form of objects. Like user is an object, profile is an object, validation rule is an object, page layout is an object, lookup filter is an object, business process is an object, email template is an object, group object, workflow rule object. We have two more objects are also available, like custom object. The object name itself custom object, which will store all your custom objects. Whatever the custom objects that we have created, all those objects information will store inside an object called as custom object. The name of the table itself, custom object. And we have custom field. This is also an object which contains all your custom fields. Whatever the custom fields that we have created, all the custom fields information will store inside that. Like that here, we are having some set of objects which are available in the form of features, but we are managing them in the form of, okay, by using declarative development. These objects are called as setup objects. So, setup objects are used to interact with the metadata through declarative development. These can be manageable with the help of okay, setup area or builder area of Salesforce. Now, apart from the setup objects, whatever the remaining objects are available, those are comes under non-setup objects. Remaining objects, including standard or custom, those will be called as non-setup objects. Now, if you want to see what are the list of setup objects that we have inside your Salesforce org, just we can go to that Google and we can verify. Setup objects in Salesforce. These are all are the setup objects here. So now we can use the setup objects to interact with the metadata for declarative development here. Now we have business process, clean data service, clean rule, compact layout info, custom field, custom object, custom tab. These are all of the object names. And then we have duplicate job definition, document object, email template, entity definition, entity limit, field definition, field mapping, flexi page, flow, and the group. And we have keyword list, layout, all the it will store all the page layouts over here. Lookup filter, matching rule, menu item, and the profile. And then we are having this quick action, record type, search layout, user, and we have web link, validation rule, workflow alert, workflow field update, workflow outbound message, workflow rule, and then workflow task. These are all are nothing but setup objects in Salesforce. Except these objects, whatever the other standard and custom objects that we have inside of Salesforce are, those all are called as non-setup objects. Okay? Now, so now in this case here, what is the problem with these objects? Whenever we are performing the DML operations on both setup objects and the non-setup objects within a single transaction, when you try to perform the DML operations on both the setup objects and non-setup objects within a single transaction, it will raise an exception, mixed DML operation exception. Okay. Upon performing the DML operations on both the setup and the non-setup objects within a single transaction, it will raise an exception, mixed DML operation exception. So now, if you want to avoid this kind of mixed DML operation exception, then we can use the help of a feature called as future methods. Okay. Understood the concept here? Clear up to this one? Then, how can we prepare these future methods? We'll see one by one. Okay? Now, make a note of this one. Salesforce provides a collection of objects as part of Salesforce CRM, which in to store the CRM related data, which includes both standard and custom objects. Now, All the Salesforce objects has been divided into two types. First one, setup objects. Second one, non-setup objects. Setup objects means these objects are used to interact with the metadata through declarative development. Through declarative development. And we can manage the setup objects and we can manage the setup objects through setup area or builder area of Salesforce. We have a collection of setup objects as below. Non-setup objects. The remaining standard and custom objects available in Salesforce will be called as non-setup objects. For example, account, contact, opportunity, lead, campaign, hiring manager, etc. And then we are having this note. While performing the DML operations on both setup and non-setup objects, it causes an exception called as mixed DML operation. Now, to avoid this exception, we can use the help of future methods. Done with this? Now, let's see. By using future methods, we can perform long running operations. Long running operations, which includes millions of records processing, which includes millions of records processing, or can integrate with the third party systems also. Future methods will always be executed by placing inside the apex queue. That is, these are purely asynchronous methods. By placing inside the apex queue when the Salesforce resources becomes available. Now, note, always future methods should be prefixed with the annotation at the rate future. So that already told you today, future methods are not executing within your organization. These are always executing outside of the organization by placing inside the Salesforce queue. Whenever the resources becomes available, then it will execute, it will send the response back to you. Then how can we define this future method? Let's see. Then up to this part. Okay. Done with this? Now. So now let me take an example here. How can we prepare these future methods? Then first of all, let me reproduce this problem here. Whether really mixed DML operations will be exception will be getting arising or not. Now, then what I will do is I will take one setup object. I will take one non-setup object here. I will try to perform the DML operations for this two objects within a single transaction. In one method, I would like to write the business logic to perform the DML operation on setup object and to perform the DML operation on non-setup object. Let me take an object here. For example, I would like to take this user object. User is what? Setup object. I would like to take hiring manager. This is what? Non-setup objects. Then I want to perform the DML operation on these two objects. Whatever the user record that we have, I want to deactivate the user. You know how to deactivate the user already we have discussed during DML statements concept. Now I would like to deactivate this user here. So we have to go to the user record, collect the user data, and then we have a field called as is active, assign the value as false, update it back to the database. So with that we can deactivate. That means I'm performing update operation on user object. Second one, I want to create one hiring manager record. That means insert. That means DML operation. So these are the two objects here I would like to take to perform DML operations. I want to deactivate the user. I want to create hiring manager record. Let's see, whenever I'm trying to be performing this operation within a single transaction, really will it be raising any mixed DML operation exception or not? If it is raising here, then how to fix this issue by using future methods, we'll see. And then we'll see what drawbacks available in future methods and how to overcome by using queuable interface. We'll see with practically. Okay. Now, let's see that. Let me take that use case. I'm going to my Salesforce R. Now let me take a user record. Let me take a user. For example, I would like to take a user, testing user. Is the testing user is in active status or inactive status? Active status. Now I want to deactivate this user here. Okay, I want to deactivate this user through programming. Just we have to go to this is active field. We have to assign the value as false. Okay. Right now it is in active status. Now I would like to make it deactivated. Second one, I want to create one hiring manager record as well. Let's see. Go to the developer console. Let me create an Apex class. I'm creating a class with the name future methods helper. And inside this class, I'm preparing the method. Public static void do DML operations. I'm preparing a method with the name do DML operations. I want to perform the DML operations on both these object records. One user record, one hiring manager record. Now, let's see. Deactivate the user. I want to deactivate the user first. How can we collect this user record? Okay, now let's see. Select the ID of the user, first name, last name, username is active from user object, where username equals to, I would like to pass this username. I'm passing the username. So now here I would like to collect the user details based on this username. Now tell me, with this username, how many user records will be available? Only one. So now, because that already we know, usernames will be always unique across all the region servers. So with this username, only one user record will be available. I'm storing this user record inside this variable. User, user info. I'm collecting the user details. I'm storing inside my variable. Now I would like to check the condition if the user record is available. If user info dot id not equals to null, then I would like to deactivate. Then what we can do? User info dot is active equals to false and update the record. That's it. So now I'm going to be deactivating this user based on this username. So whatever the username that I have supplied, based on the username, I'm collecting the user record. I'm deactivating this user. And then I want to insert a new hiring manager record as well. Let me create the object of this hiring manager class. Hiring manager HR record equals to new hiring manager. I'm creating the object of this class. I would like to supply the values. Let me save this code. HR record dot name. I'm giving the name as some Arvind Kumar. Location, I'm passing the value some Chennai. Designation, some HR executive. Employment type, he is a permanent employee. Contact number, email ID, current CTC. I'm inserting the hiring manager record. I want to show the confirmation. If HR record dot ID not equals to null. Now I would like to show the confirmation. System dot debug. Hiring manager record inserted successfully. Now we are representing the recorded details. Clear? So now here what I'm doing, I'm performing the operations on two object records. First one, I'm deactivating this user, which is a setup object. And then I'm going to be inserting a new hiring manager record, which is a non-setup object. Okay. Now, just give me a minute. I will be back. Now, so now here these are the two objects which we are interacting right now. We are deactivating a user record. That means you are performing DML operation. And then I'm inserting a new hiring manager record, one more DML operation. But both the piece of code I have prepared within a single method itself. When we try to execute this method, then it will try to deactivate the user record. It will try to insert a new hiring manager record also. So whenever we are performing the DML operations on both setup and the non-setup objects within a single transaction, it will raise an exception. Now, let me try to invoke this method. I'm using this method, future method helper dot. What is the method name? Do DML operations. Now, click on execute button. Now it is raising an exception, like a mixed DML operation exception. So it is clearly indicating that DML operations on the setup objects are not permitted after updating a non-setup object or vice versa. That means they're clearly indicating this. The DML operations on setup object is not permitted after you have updated the non-setup object or vice versa. That means even though you make it reverse, it won't support. Okay. So because here there is a conflict. Okay, there is a conflict that we can't use both the setup objects and non-setup objects within a single transaction. Then what we can do? In this case, we need to divide this piece of code into two separate methods. Let me try to do that here. Because both the piece of code I have written within a single method, that's what it is going to be raising an exception. Now let me try to divide this feature into the two different methods. I'm deleting this piece of code from here. I'm preparing one more method. Now, I'm writing the piece of code in a separate method. Hiring manager operations code I'm writing within a separate method, and the user object deactivation will be in a separate method. I would like to call this a method here. I'm calling this method from here. I'm making it as a chaining functionality here. Okay, chaining methods. So instead of writing the code in one single method, I have separated the code into two different methods also. But even though if you are writing this code in two different methods, but both are executing in one transaction, right? Yes, because whenever I'm invoking this method, it will be starting the transaction. It will start the transaction. Under this transaction, it will execute the user code. As soon as the user has been updated successfully, immediately it is calling the second method also. That means HR record method. That means both are executing within one single transaction, right? Again, it will raise the same exception. Okay. Again, it will raise same exception. Now let's see. Click on execute. Same exception will be getting erased. So now here in this case, it is not at all permitting me to execute both this operation under one go. We have to execute the first method separately, second method separately here. Then only it will be executed here. Or else it will show this message mixed DML operation exception. Now for that reason, I don't want to execute them two times separately here. I want to execute only one time. But the thing is, both should be executing in two different transactions over here. Now, for that reason, what I want to do is, upon invoking this do DML operations method, it maintains a transaction. It maintains a transaction. Is the transaction. Transaction 1. Under this one, it is going to be updating the user details. It will update the user details. Once the user details has been executed, then it will be invoking this method. Upon executing this method, I want to use one more separated transaction. I would like to maintain one more separate transaction, that is transaction 2. So now here in this case, if you want to execute this method in a separated transaction, then define this method as @future. Define the second method as @future. That means what? Whenever we are defining the future methods are not executing within your organization. These are executing outside of the organization by placing inside the Salesforce queue. That already we know in the previously in the batch programming. I told you each batch will be running under a separated transaction over here. That's what we can able to process 2,50,000 batches within 24 hours of time frame from an organization. Now here in this case here also, whenever I'm placing this method inside the Apex queue, to run this method, it will maintain a separated transaction. So internally they are running in two different transactions. For user record, one separate transaction. For HR record, one separate transaction. So both are executing parallelly. It won't show the error message. Clear? Now let's save this code. I'm defining this method as @future. Now let's execute this piece of code. It is performing your operation. Okay. Now this is how we can able to implement the future methods, so that we can avoid mixed DML operation exception, and then we can able to perform the operations on multiple records. Here what operation we are having? Hiring manager records inserted here. Now the second operation results I can't see. Okay. Both will not be visible at a time over here. Both are maintaining two different transactions. Let's see. Now let me check that user record. Refresh the users table. Testing user has been deactivated. Hiring manager record also inserted. Then how can we monitor hiring manager record information? Because that is under future method. Future methods are always executing from where? From a single Salesforce server. That means inside that Apex queue. So that here how to monitor that jobs. So just you can go to that Apex jobs. Now we can see the result of your batch future method. This is a future method here which we have implemented. The future method class name, we can see the class name. This is the class name future method helper. This is the future method name. And this is the ID has been allocated by Salesforce for this particular job. Whenever we are placing any method or any job inside the queue, for every job, queue will allocate one ID here. One unique identification ID will be allocating by the queue. So now we can able to check this queue ID also over. Clear? Understood the concept now? No. So now this is how we can perform the future methods as part of your implementations. Okay? Now, let me place the code. Okay? Now, so now here in this case, let me give you few note points over here. Whenever we are going to preparing the future methods, okay, we are having few rules. Now, no space. The next page. Okay? Now. So now here in this case, నెక్స్ట్ పేజ్లో రాయండి మేడం ఏమవుతుంది అక్కడ అక్కడే రాయాలని రూల్ ఏం లేదు కదా Okay. Now let's see. So now upon preparing the future methods, we are having few principles. There are some rules. Then what are the rules that we have upon preparing the future methods? Now let's see. The first principle is that already told you future method should be always prepared by prefixing with the annotation at the rate future. That is the first rule. Okay. Upon preparing the future methods, okay, each future method should be prefixing with the annotation at the rate future. That is the first rule. Second one, future method should be always defined as static. Future methods should be always defined as static. This is the second rule. Third one, future method doesn't return any value back to the calling environment. Okay, it should be always having the return type as y. That means it should be procedure. It should not be a function. Next one. Whenever we are going to be defining the future methods are not executing within your organization. These are executing outside of the organization by placing inside that Salesforce queue. These are the four principles are available upon preparing the future methods. Okay. Now, so while using this future methods, there are some limitations. Okay, there are some limitations or drawbacks are available here. What are those drawbacks? We'll see one by one. Okay, now make a note of this one. Future method name should be always prefixed with the annotation at the rate future. Second one, future method should be always executed by placing inside the apex queue. That is, these are asynchronous methods. Third one, future method should be always defined as a static. Fourth one, future method won't return any value back to the calling environment. That is, it should have the return type as void. These are the four principles are available upon preparing this future method. We'll have the session till 9:30 today. Okay? By 9:30, I will close it off. Okay? Upon future done next. Now, upon using these future methods, we are having few limitations. Are drawbacks. Okay. So while using these future methods, okay, we are having few limitations or drawbacks. Then what are those limitations that we have? Now let me explain. Let me explain with the practical first. Now let's see. This is a future method. Create new HR record. Observe the scenario. Can you pass any parameters for these methods? Yes, we can pass. I'm passing the parameter here. Integer, customer code. I'm saving this. Code has been saved successfully. Compile code. I'm passing a string value. Now, it is also saving this code over here. Code has been saved. I'm passing ID. I'm passing ID parameter. Code has been compiled successfully. I'm passing a integer array. Integer array product to quotes. Now the code is saved successfully. No compilation error. I'm passing a string array. I'm passing a string array as a parameter. Now it is saving this code. Code has been compiled successfully. I'm passing list collection. List of ID. Record IDs. I'm passing the list of ID. Code has been compiled. I'm passing list of string. Now here I'm compiling the code here. Code has been compiled successfully. Now I'm passing one account record parameter. Compiled or not? Code has compiled or not? Error. Now, what is the problem? Anything. I will use that account object parameter wherever I want. Hmm. Do not? Why? See, if I'm writing up to like this, do we have any errors? No. I have passed 7 parameters almost. Now I'm passing one parameter, suppose for example lead. Hmm. Then in this one we are doing the operations are non-setup only, right? Lead is what? Of type what? Standard object. Okay, fine. Then, so what about the data type here? This is nothing but data type. This is the data type parameter name. Right, correct. In this case here, Whenever we are preparing the future method will supports to pass the parameters also. But we can pass the primitive type of parameters. Arrays of primitive, collection of primitive. But future method do not support a subject type of parameter. When you try to pass either account type also, lead type also, case type also, user type also, hiring manager type also, it won't support. Okay. Now let me try to pass hiring manager type. It won't support. It will show the same error message over here. Future method do not support parameter type of hiring manager. So this is the first drawback. Whenever we are passing the parameters to the methods, generally any method can able to support all the types of parameters. Primitive type, a subject type, arrays of the primitive, collection of primitive, arrays of a subject, collection of a subject, everything will be supported. But when you go to the future method will support to pass the parameters of type primitive, arrays of primitive, collection of primitive, but not a subject type of parameters. Yes, subject type of parameter cannot be supported by future method. This is the first problem. Okay, next. Second drawback, the second problem. Whenever we are using the future method doesn't support chaining mechanism. Chaining mechanism means what here? Chaining in the sense, not like that. I want. Hmm. Now, calling one method from another method here. Now here in this case, future method do not support a subject type of, so it they won't support chaining mechanism. That means what? We can't call one future method from another future method here. Now, as of now, we have invoked that this is a future method, and then we are calling from another non-future method here. Like that here, when you try to call one future method from another future method, then it won't support. This is the second problem here. Okay, next. Third problem. Now tell me, future methods will be executing by placing where? Outside of the organization. From where it will execute? Again, Apex queue. Whenever we are placing a job into the Apex queue will be allocating one ID, right? Yes. If we are aware of the ID, we can track the status of that job through programming also from async Apex job object. Now, in this case here, whenever we are pushing this job into the queue, whenever we are defining the method as @future, automatically this annotation will make this method to be placing into the queue by default. So once it has been placed into the queue will allocate one ID for the future method. But the problem is, future method will not return this ID back to you. It won't pass this ID back to you. Without getting that ID, we can't track the status through programming. So if you want to monitor the progress of your future method, compulsorily we have to use wizard format. No Apex programming concept. Okay, go to the setup menu, go to the Apex jobs, then only we can see the result. But if it is a normal batch processing, how can we track the status by using async Apex job object through programming? But that option is not available here. Why? We don't know the ID of that future method. We don't know the ID. If you don't know the ID, how can we track the status? It will be very difficult. For that reason here, when coming to the future methods, we can't track the status of the future methods through programming. These are the three major problems are available in future methods. The first problem is future method doesn't support a subject type of parameters. Second one, future method doesn't support chaining mechanism. Third one, we can't track the status of the future methods through programming here. These are the three problems are available here. To avoid these three problems, we are using the help of an extension that is called as Queueable interface. That is also called as Queueable Apex. So now by using this Queueable interface, we can able to avoid all these three drawbacks of future methods. What are the three drawbacks that we have identified in future methods? All those three drawbacks we can overcome by using Queueable interface. By using queueable interface, we can pass a subject type of parameters also over here. By using queueable method interface, we can able to implement chaining mechanism also. By using queueable interface, we can track the status through programming also. That possibility is available. So now for future methods, we have an extension that is called as queueable interface. Then how to use this queueable interface, we'll see practically today. Okay? Now, make a note of these three limitations. First limitation. Future method do not support to pass a subject type of parameters. That is, we can supply primitive type, arrays of primitive, and collection of primitive type. But we can't pass a subject types. Second one, future methods won't support chaining mechanism. That is, we can't invoke one future method from another. Third one, we can't track the status of the future method through programming. That is, while placing the future method inside the queue, then it won't return any job ID back to the calling environment. Now, to avoid the above limitations, we have to use the help of queueable apex, that is also called as queueable interface. In reverse, 1 hour పడుతుంది ఇంకా 1 hour పడుతుంది. Done with these points. Now let's see. So now to avoid the limitations of the future methods, we are using the help of queuable interface. So basically, queuable interface is an extension for future methods. Queuable interface is an extension for future methods. So in future methods, what are the three drawbacks that we have identified? These are three drawbacks we can able to overcome. Now, then why we are using this queuable interface? Queuable interface is also used to implement long running operations. Whenever we are performing certain operations, which include some millions of records processing, which will take some more time to be get processed, those kind of operations we can implement with the help of queuable interface. Now, these queuable interface classes are also executing by placing inside the Apex queue. These are not executing within our organization. These are also purely asynchronous operations which will executing by placing inside the Apex queue. Now, so now here in this case, by using this queuable interface, we can implement chaining mechanism also. That means one queuable class can invoke another queuable class also. And we can able to pass yes subject type of parameters also to the queuable classes. And then we can track the result of this queuable classes also through programming from async apex job object. So that facility is available. So now in this case, how can we prepare this queuable interface? In order to implement this, we are using the help of an interface called as queuable interface. That means system.queuable. We are using the help of an interface called as system.queuable. Okay, system.queuable interface. Then how to implement this system.queuable interface? What kind of steps that we used to follow? How to push this queuable class into the queue? How to monitor the results? We'll see step by step approach. Okay, now make a note of this one. Queuable interface is an extension for the future methods. Queuable interface is an extension for the future methods to avoid all the limitations of future methods. By using queuable interface, we can implement the long running operations, which includes the millions of records processing. Queuable classes are also executing by placing inside the Apex queue based on the availability of the Salesforce resources. Now, in this case, we can supply a subject type of parameter to queuable classes. And we can implement chaining mechanism. That is, one queuable class can invoke another queuable class. And we can track the result of the queuable class through programming from async of its job object. To implement the queuable interfaces or queuable apex, we have to use an interface system.queuable. Then how can we use this? Okay, we'll see. Implement